In this video, I am going to explain numerical problems of resistance and Ohm's law. Page number 125, practice problem number 1. A wire of resistance 4.5 ohm and length 150 centimeter has area of cross section of 0.4 centimeter square. Calculate specific resistance of wire in SI unit. So here given is your R equal to 4.5 ohm, that is resistance, L equal to 150 centimeter. So convert it into meter by dividing by 100. It will come as a 1.5 meter. A is given as a 0.04 centimeter square. Convert this centimeter square in meter square by dividing 100 square. Then solve it. After solving, we'll get here 0.04 into 10 to the power minus 4 meter square. Now, since in the question we have to find the specific resistance, so write down the formula for the specific resistance, that is rho is equal to RA by L. Rho is the symbol of specific resistance. Put the values, and after putting all the values, solve it, and you will get the result as a 0.000012 ohm meter. Now practice problem number 2 is same as question number 1. So you try yourself. Now see the number 3. The resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? So here R is given as a 26 ohm, L is given 1 meter, and here cross sectional area is not given but diameter is given as a 0.3 millimeter. Now we know that cross section means the circular part, and the circular part area is always pi r square. Now since the diameter is given, so you can find easily radius by d by 2. So pi d by 2 whole square is your cross section area. Now put the values. Pi 22 by 7, d as a 0.3 into 10 to the power minus 3 and divide by 2 whole thing square. Now just open the bracket and solve it. You will get the cross sectional area as a 0.0707 into 10 to the power minus 6 meter square. Now since we have all the quantities of the specific resistance, now put the specific resistance formula, that is rho is equal to RA by L, and put all the values, and after putting the values do the calculation. Now page number 126, practice problem number 2. Resistance of a conductor of length 75 centimeter is 3.25 ohm. Calculate the length of a similar conductor whose resistance is 16.25 ohm. So here resistance of a conductor, length is given, L1 is given 75 centimeter, and you have to find the length of another conductor of similar, means another length of the similar conductor. So R1 is here 3.25 ohm, R2 is given here 16.25 ohm. So since the material is same, it means your rho 1 is equal to rho 2. Now if you write the formula for your rho 1 is equal to rho 2, that is your R1 L1 by A1 is equal to R2 A2 L2 by R1 A1 by L1 is equal to R2 L2 by A2. Here same wire and the cross sectional area is also same, so you can use directly this formula, that is your R1 by R2 equal to L1 by L2. Now put the values of R1 and R2, L1 and L2. So cross multiply it and solve it for L2. It will come as a 375 centimeter. Now question number 2 of practice problem number 2, that is same as your this number 1. Here L1 is given 85 centimeter, R1 is given 3.75 ohm, L2 is equal to 510 centimeter and R2 you have to find. So again use the same formula, R1 by R2 equal to L1 by L2 and find out the R2. Now page number 126, practice problem number 3. Practice problem number 3. Part 1. A resistance wire made from German silver has a resistance of 4.25 ohm. Calculate the resistance of another wire made from same material such that its length increases by 4 times and area of cross section decreases by 3 times. So here you have to take the German silver wire, first wire, and again the German silver wire, second, consider as a second wire. So here R1 is given 4.25 ohm, R2 you have to find, and since both the wire is made up of the German silver, so R1 and R2 will be same, that I consider as a rho. Now for the first wire I have taken here L1 as a length, A1 as the cross sectional area, and according to the question L2 will be 4L1 and A2 is equal to A1 by 3. Now again here rho 1 is equal to rho 2. Since they are made up of the German silver, we can write rho 1 equal to rho 2. Write down the formula for the specific resistance, that is RA by L. So R1 A1 by L1, R2 A2 by L2. Put the values, cancel the common terms, and after solving you will get the R2 equal to 51 ohm. Now in the same way you have to do question number 2. A nichrome wire of length L and area of cross section A by 4 has a resistance R. Another nichrome wire of length thrice L and area of cross section A by 2 has a resistance R1. Find the ratio. Here you have to find ratio of R1 is to R2. So in the same way as question number 1, write the nichrome wire, first wire, second wire. Take the rho 1 and rho 2, both are same as rho because they are made of the same material, that is your nichrome wire. Now L1 take as a L, A1 according to the question is A by 4 and R1 equal to R according to question. Now according to question L2 is given thrice L, A2 is given A by 2 and R2 is given R1. Again use rho 1 equal to rho 2. Write down the formula of rho 1, that is R1 A1 by L1, R2 A2 by L2. Put the values from this chart, rho 1, R1 A1 L1 and R2 A2 L2. After solving you will get here R1 is to R equal to 3 is to 2. Now question number 3. A 4 ohm resistance wire is doubled on it. Calculate the new resistance of wire. Now whenever you double the resistance, suppose this is the length and if you are doubling this one, on that time the length is always decreases by half and the cross sectional area always increases by twice. So in this question R1 is given as a 4 ohm. Take all the L1, A1, rho 1 as a L, A, rho. Now on doubling the wire we have L2 decreases by L by 2, A2 equal to twice A, rho 2 equal to rho, and you have to find the R2. Now here again rho 2 and rho 1 is same because the same material wire we have taken. Now again same process, rho 1 equal to rho 2, write down the formula for the specific resistance of the first wire, for the second wire, put the values, cancel the common terms and you will get R2 as a 4 by 4 which is equal to 1 ohm.